So we're going to continue the pregnancy problem, and this is in the Chapter 5 notes. So the boss steps in. Let's suppose that the boss lets the dad cancel the second trip and wants the future dad to plan the first business trip to end when there would be a 99% chance that he would be at home for the birth. Okay, so if we're just thinking about this real quick, there's no business trip at the top end, right? None at the, no second trip, and we have this first trip that used to end at 85 days, but he's gonna let the dad basically come home early so that there's a 99% chance that he'd be home for the birth. So when should he return home? When, at what point, how many days into the pregnancy would there be a 99% chance that the dad would be home? So we have to, we're working from this side over here. To make it a 99% chance, basically I want some value down here, let's say, and I want all of this area to represent the probability or area, interchangeable, remember. I want this to be 99%. Okay? So in order to do that, you could think of it this way, right? So this area over here needs to be 1%. But it doesn't really matter which way you think about this. Either way that you think about it, we have to work backwards. Okay? Now, normally we figure out what the z-score is that's represented here. And, we find out what area we have as a result. Now we know what area we want as a result. Now we got to find out what data value goes with it. Okay, so there's a 99% chance of making it home on time. Then there's going to be a 1% chance of not being home on time. So using the table in reverse, we're going to look for a z-score that corresponds to 1%. Okay, so 1%, 0.01. Make sure you get your decimals right. Probabilities, or the area, remember, is in the body of the table. We need to find 0.01, and since there's 4 decimals, we're going to look for 0.0100. We're not going to find that exactly, probably, so find the closest thing to 0.01. So pause the video if you need to, see what you get. And be careful with the decimals. It's easy to be looking in the wrong place. Certainly we need to be at the negative side of the table because we're only talking about a small area down here. I guess I should redraw it here. I'm looking for this value. The mean is 100. And we want this area. Actually, let's do it this way. We can look for this area to be 0.01. We need the value. So, looking at the table, it looks like there is a 0.0099 and a 0.0102. So 0.01 is in between those two. So it's between, let's see if we read these, between negative z-scores of negative 2.33 and negative 2.32. Which one is it closer to? It's closer to this guy. That's only off by 1 10,000ths. This one is off by 2 10,000ths. So this one's closer, and that's generally what we'll do. Just pick the closer one. So we'll use this z-score here. And now what we have to do is find out what data value, or instead of the question mark here, think about it. This is the x value we're looking for. What x value goes with this z-score? You remember the formula. The z-score is, x minus x bar over standard deviation. So in this case, negative 2.33 is equal to some x value we're trying to determine, some number of days, minus the mean of 100, divided by our standard deviation, which I think was 8. If you solve this for x, I'm going to do a few things here at a time. Multiply 8 times negative 2.33. Okay, that would be over there, and then add 100 to both sides. And that would give us our x value. So if we put that in the calculator, we get x equals 81.36. So around the 81st day is when Dad would have to come back for there to be a 99% chance that he is here for the birth. Okay, so that would be a 1% chance that the birth occurs before he comes back. So let's compare that to what the original problem said. The original problem had him sitting here at day 85 was his plan to return. That gave him a 3% chance of missing the birth on the low end of the problem. So this improves it a couple of percentage points by coming home 4 days earlier. Okay? If we were doing this with the calculator to help us, there is a function called inverse norm. So in your calculator, it's under second distribution. It's actually the same place that the normal CDF is. We're going to use inverse norm and basically do the normal CDF in reverse. And in inverse norm, it asks, what area are you interested in? And I'm just going to use the area to the left. Some of the newer operating systems allow you to do area to the left, center, or to the right. I'll just use to the left. So the area I'm interested in to the left is 1%. And it wants to know the mean and standard deviation. So I'm going to put in 100, standard deviation of 8. And it's going to tell me what day Dad needs to come back in order to have only a 1% chance of missing the birth. Now it's going to be a little different than this because we had certainly some rounding here. And actually we couldn't find the exact number of 0.01 on the table. But the calculator does a much better job. So let's take a look at that. Okay, so second distribution. That is not second distribution. Second distribution. We're going to do number 3, inverse norm. And the area we're interested in, 0.01. The mean is 100. Standard deviation was 8. And the tail, we're going to just look to the left here. We're going to paste that. Hit enter. 81.38. This means, day 81, so 81.4 days from the current date is when he needs to return. That is super close to what we had before. Right? It's off by an insignificant amount. So Dad needs to return at day 81 to have only a 1% chance of missing the birth. So it's nice of his boss to allow that. All right, well, hopefully this makes you feel more comfortable about using your calculator and these Z-scores.